If you place a French Leclerc tank next to an American M1 Abrams or a German Leopard 2, the physical differences are immediate. The Abrams and Leopard are massive, tipping the scales at around 70 and 67 tons respectively, and each requires a 4-person crew to operate. The Leclerc weighs just 56 tons and runs with a crew of 3. During the late Cold War, NATO doctrine demanded heavily armored giants to hold the line against Soviet armored divisions in Central Europe. France faced a different strategic reality. They maintained military commitments across North Africa and the Middle East, requiring a rapid reaction expeditionary force capable of intervening on short notice. Trying to airlift or ship a 70-ton armored vehicle across the Mediterranean or deep into sub-Saharan Africa is incredibly difficult. Every extra ton severely limits the number of tanks that can be loaded onto transport planes and cargo ships. France originally attempted to co-develop a new tank with West Germany. But because Germany prioritized heavy armor for a European land war and France required extreme strategic mobility, the partnership collapsed. France moved forward alone to create the AMX Leclerc. To meet these strict deployment requirements, French engineers had to discard standard Western tank designs and build an entirely new architecture from the ground up. The most significant weight-saving decision was replacing the human loader with an automated loading system for the 120mm smoothbore gun. While Soviet militaries had used autoloaders for years, their designs were notorious for catastrophic ammunition detonations when hit. French designers engineered an isolated, highly protected magazine compartment that reliably fed rounds without exposing the crew. Removing the 4th crew member triggers a cascade of design benefits. Without a loader standing inside, the internal volume of the turret shrinks. A smaller turret requires less steel and composite plating to cover it, which shaves off tons of overall vehicle weight. This automated mechanism also allows the gun to maintain a consistent rate of fire, even while the vehicle is sprinting at top speeds over severely uneven terrain. To propel this lighter chassis, the Leclerc relies on a unique propulsion system, the SACM V8X Hyperbar engine. This engine acts as a mechanical hybrid. It pairs a traditional V8 diesel block with a gas turbine. Exhaust gases are used to spin the turbine, which acts as an extreme supercharger, forcing highly pressurized air back into the diesel engine. Looking at this split graph, we can see the direct results of that design. On the left, the acceleration curve shows the Leclerc jumping from 0 to 32 km per hour in just 5 seconds, matching the responsiveness of a gas turbine. On the right, the range metrics show it maintaining the long-range fuel efficiency of a standard diesel, achieving 550 kilometers on internal tanks. Pairing a Rapid Autoloader with the Hyperbar engine gave the French military exactly what it needed, an agile striker optimized for high operational speed. For protection, the tank utilizes a modular composite armor system. Instead of being permanently welded on, these protective blocks are bolted to the hull and turret, allowing crews to quickly replace damaged sections or upgrade to new materials in the field. International defense analysts were highly skeptical of this setup. Many argued that the complex engine, automated turret, and lighter armor profile made the vehicle too fragile for actual warfare. That theory was put to the test after the United Arab Emirates purchased 388 modified tropicalized versions of the Leclerc for their own armor divisions. In 2015, the UAE deployed these tanks into the Yemen Civil War, thrusting them directly into brutal close-quarters combat. The battlefield data proved the design worked. Several tanks took direct hits from anti-tank mines and rocket-propelled grenades. The modular armor absorbed the impacts, and the sensitive autoloader systems operated flawlessly despite the punishing heat and abrasive desert sand. The deployment in Yemen silenced the international critics. It demonstrated that a lighter, automated tank could survive urban ambushes and dominate in a modern combat zone. While the original mechanical design entered service in 1992, success on a modern battlefield requires digital superiority. To keep the platform current, the French military initiated the Scorpion modernization program, introducing a heavily upgraded variant known as the Leclerc XLR. The physical upgrades include specialized urban combat armor packages to counter improvised explosive devices, along with a new remote-controlled weapons station mounted on the roof. The critical upgrades are internal. The XLR features advanced tactical sights, updated optics, and a completely new battlefield management system that turns the tank into a networked data node, allowing it to instantly share target information with allied units. These electronic integrations bring the tank's situational awareness up to current standards, ensuring the vehicle remains lethal and effective well into the 2040s. By refusing to copy its allies and engineering a solution tailored to specific strategic constraints, France built a highly adaptable armored vehicle. The Leclerc proves that maximizing weight is not the only way to build a dominant tank.